Ever tried putting together a puzzle only to realize some pieces are missing? That's essentially what data scientists encounter daily, datasets riddled with gaps that distort their models. But here's a breakthrough. Researchers are now leveraging quantum computing to tackle this problem, and the approach is anything but conventional. Let's break it down. Missing data isn't just an inconvenience, it's a fundamental challenge. Imagine building a model to predict house prices, but some entries lack critical details like square footage or location. Traditional methods like mean imputation or simple regression often introduce biases. These techniques treat data as linear and static, ignoring the complex, nonlinear relationships that real-world datasets inherently possess. Enter large language models, the same AI tech powering chatbots. These models excel at pattern recognition, but even they struggle with datasets blending numerical, categorical, and textual data. Why? Because they rely on embeddings, mathematical representations that map data points into lower-dimensional spaces. Think of embeddings as simplified roadmaps. They capture relationships between data points, but often oversimplify the terrain. For instance, a classical embedding might struggle to link a sunny weather description to a sales spike, treating them as unrelated due to their different data types. This is where quantum computing steps in. It's not sci-fi, it's a tangible tool reshaping data science. The paper introduces Quantum-UnIMP, a framework that replaces classical embeddings with quantum feature maps. These maps are generated by quantum circuits, which process data through quantum phenomena like superposition and entanglement. Here's the technical kicker. A qubit in superposition exists in multiple states simultaneously, while entanglement creates correlations between qubits regardless of distance. Together, they enable quantum circuits to encode data into high-dimensional, nonlinear spaces. For example, a quantum circuit could represent a sunny weather entry and a sales figure as intertwined states, revealing hidden patterns a classical model would miss. This isn't just about more dimensions, it's about capturing relationships that defy classical geometry. The results? On benchmark datasets, Quantum-UnIMP reduced numerical data errors by 15% and improved categorical accuracy by 8.7%. Even with today's noisy quantum hardware, devices prone to errors due to environmental interference, the framework shows promise. This suggests quantum computing isn't just a theoretical luxury, it's a practical tool for real-world data challenges. So what does this mean for the future? Quantum computing isn't just for cryptography or molecular simulations. By integrating quantum-enhanced embeddings with AI, researchers are unlocking new ways to handle messy, heterogeneous data. This could revolutionize fields from finance to healthcare, where missing data often undermines predictive models. Next time you encounter a dataset with gaps, remember, the solution might lie in the quantum realm. Thanks for watching. Hit subscribe for more deep dives into the science redefining our world.